So I'm making an experimental change today. The idea is from yesterday where we had a couple of tracks where we could see if this can be improved, this performance could be improved. One was to see if the HTTP stack could be improved. The second was the sync pool, which is the thread pool abstraction layer for us to work with concurrent requests, right? If any of these two could be done. So I was looking at a couple of threads out there to see if there is a scope for net HTTP, but I have my doubts. But one thread that gave an interesting way to deal with this is to use the download file option, where uh, a lot of change would not be required at the header level, and this might be a little faster compared to our fetch or our HTTP GET. Well, I'm skeptical. I'm just giving it a shot at the moment. So the idea here is I need to write this, download this file into a local file, the HTML into a local file, read from that file as the content, right? Now, how do I do it? I just can do the do a write into some temp file, the temp file system, and when the machine cleans up the temp file system, it gets removed. That's one way where I can just use some kind of a random UID as a file name for each of the requests. That's one thing, right? But where I am a little skeptical about this entire thing is yes, this a socket opens a file descriptor and transfers and closes the file descriptor. But what happens here is that now we open a file descriptor, and even if you do some kind of a what do you call zero copy and transfer the contents from the WebSocket, not the WebSockets, but the socket that connects to the HTTP connection or outside to the world. If that socket has a zero copy into a new file handle that is created underlying, or it is created as a link, link into it, right? You avoid one OS call, but you still have one more read call on the same file descriptor, right? You are doing one more file call. Is that in some sense equivalent to all the header processing and everything that is supposedly uh, the bottleneck as this thread, random thread, by the way, that I came across? I have my doubts regarding that, but nonetheless, it is worth an experiment. So here goes nothing. The idea here is to have a random UID for every request, and that being the file name.html inside the tempfs. So I'm importing rand, which is the random module, pseudo random to be very honest, for those that are very cautious about naming things. And if you look at this, there have been a couple of changes here where some of these changes have been abstracted to two new methods to remove the metrics and checking if it's a static file or not. Right. So I am concerned only about the links in the page that link out, link in, and all those things, and not uh, font files, images, or PDFs or whatever. So yeah, that is one thing. And second thing, that's a very interesting observation that I had, which I missed in the previous videos, is the regex in VLang is not PCRE. For the uninitiated, PCRE is Perl compatible regular expressions. So this is not the most standard regular expressions. Regular expressions started being a major thing with Perl, and that is a standard way to write a regular expression and parse it, right? This has its own quirky flavor to it. So the outcome here is that this regex, which is standard for most use cases, has two problems. One, when I do this regex, the link matcher, and then match on it, right? Despite this being the only named group, what gets captured is this entirety starting from href, which is a really odd thing. Second is this quotes around here that also gets captured, double quotes, right? Now the problem for me here is that A, I will have to then split on this href once, and then they'll have to split on the double quotes. So which look at it as a fix me here. I could either fix it with the proper understanding how this regex works and write a VLAN compatible regex and fix it, or just stick with it for the time being until I figure a different, entirely right way to do it. So getting back to the genesis of this video, what are we trying to do here is we are trying to fetch the content. Now, how we are doing it is http.getText. What are we trying to do now is to download it into a temp file and then read from the file, right? How are we going to do it? One, uh, we need a file path. File underscore path equals, uh, let's say, ran.uid underscore v7. That is the method that gives you the UID v7. Now, the beautiful part about string interpolation is you don't do an F string and everything. You just do a single string and then inside it you do slash tmp slash and then this, like how JavaScript does it. You don't need a backtick unlike JavaScript, or you don't need a F string sort of a prefix unlike Python. So now that we have .html again, now that we have the file path, what do? We do http.download underscore file, or is it file underscore download? Let me verify the, yeah, it is download underscore file. You download the URL into the file path. Now that it has downloaded, content equals, I need to read it from the file. So I am assuming it is os underscore read underscore os dot read underscore file. And just like Go, you assign it with a colon equal to, where you don't specify the types, it automatically infers it and then translates it out, transpiles it out. File underscore path. Now this content is fetched via this. The I do not have one more RM file or any of that sort because this is written into the temp fs. For now, I think it for an experimental change, it is not that much of a concern. So let's see how this goes. I have my watcher script here, which is basically an fs watch that does a make and a make run target, which is compiles and then runs it against a couple of test URLs that I have here. So I'm saving the file. It should automatically build. Yeah. So here comes the interesting part. How do you do? Now, a download file is subject to failure. So naturally, the next thing is exception handling. So you do a try except or a try catch, right? How do you do it in VLAN? It is simple this way. If you have an assignment in here, let's say A equals some download file or something of that sort, you do the assignment here, the fallback assignment here, or in this case where my use case says, hey, if I'm not able to download the file, there is no point in proceeding with it, right? So I return a default value, which is return web. This struct has to be allocated on the heap. Otherwise, pretty much everything is at the stack level. It's a empty content 0, 0, and 0. All right, now this is taken care of. Now, if you look at why this is this way, it is because the struct has the content, which is an empty string in the case of a failure. The URL comes through as it is. Fetch duration, I am failing in fetching, so there is no point in giving the fetch duration or the link parse duration. The links, I have not fetched any content, so the links is empty. The link count is also empty, right? I'm doing an undo and redo so that it's easy for me to navigate to that location. So I'm saving the file, let it build again, and hopefully there are no problems here. So here is the beauty again. The same thing, line number 45, the same exception handle if I'm not able to read the path. So I'm just copying it over now, yanking it, and pasting it in, and done. Let's build it and see how long it takes. It was about 1.5 seconds for these two URLs when I was testing with the existing set of changes to remove the JSON stack and the rest of it, right? So 3.53. Let's try it again. One more problem here is the network. It is fairly unstable and it seems to be going up and down a bit. So there is a fair bit of concern about how I'm able to test it with a base benchmark that can be trusted. So it comes down to 2.4 right now. Let me see how this can be improved, if at all. So this is the one that gets my go 10 seconds for a compile, 3.5 seconds. Okay, under the current network circumstances, the average is about 2.5 seconds. It is not any less than 1.5. But just for a baseline comparison, let me try my original C pipelines timings. If that has also increased, then it is a case of, yeah, so there is a sig fault there which I need to look into. That used to be around zero point 0.8 seconds, which has gone up to 1.2, which means there is a network delta here. Uh, n number of reasons, including my tethered connection. So at any rate, this now gives me a baseline number of 2.5 seconds in this network condition, right? Now what I'm going to do is take this block off and see how this performs. The last known good number is 2.19. Now this compiles and is still fine to be imported without using. It's a warning. 10 seconds done. 3.1. 2.1. It's come back to the nominal number. So despite that additional OS call, system call, it seems to be fairly at the same range. So that makes me wonder if this is a zero copy, or B, if the headers parsing and the rest of them, the hypothesis that was there in the thread is, as a matter of fact, something to be believed. But for all practical purposes, it does not add value. So down the drain it goes. Now that done, there are a couple of more options here. One is, say, is there a better way to do the HTTP call itself, which is to go to the level of sockets? Can we do something on those lines? If that is a feasibility, then we should experiment on that part, which probably is going to be my next thing. And the other thing that I wanted to draw notice to is this pool processor itself, right? Max jobs is an argument to this pool processor where it tells the pool processor, hey, this is the number of jobs that you can run in a concurrent manner. They call it parallel, but I have my hunch that it is concurrent and not really parallel, because it's backed by threads on top and a number of abstractions on top of it. So what happens when I don't provide it? It lets the system figure it out based on the number of cores available in the in the system, the number of threads available in the system, and the nominal amount of threads that can be spawned out for performance, right? It is the same content, direct fetch, and I have removed the argument to tell the system, hey, you figure it out. Is it going to be any better? Let's see. 2.8. Second run for concordance and for science. 2.7. Let me see if I can undo this and try it again. So there is something else that has failed here, which I would probably have to look into. In my C binary, there is a malloc failure. The classic malloc failure. I would assume this is probably because of the recent change that I made to free up some pointers, which I would probably get back into to do a debug fix. And speaking of, we have come back down to the point of 1.9. So this does not seem to add a lot of value at this point in time. So this is off the plate, but there is still some scope to see if the pool processor can be stripped bare metal to the point of handling raw threads. If the language provides some kind of a C interface that would allow me to do that, at which point the question then comes, hey, you might as well write it in C. Why do you do this? The question is on the same lines of, hey, why do you need Python? Why does Rust provide you an ABI for C? Same. The language at large provides a lot of very good primitives and abstractions that allow you to not worry about things like memory. For example, this very classic case of free that fails. And if you look at something like Zig, it goes the same. Uh, it's on the same spiritual lineage as C and takes the same thoughts to mind, right? But here it takes care of all your memory concerns and everything and still provides you an additional way. So that's flexibility that would be required for a power user at some point. That is the next experimental change. Got to see how it goes. So this is where it stands as of now. And on that note, peace out.